day, and welcome to the Division of Education, Innovation and Energy e-learning program. I'm one of your maths facilitators, Frederick, and for this video, we shall be continuing our exploration of algebra, where we are going to look at algebraic fractions and, more importantly, the addition and subtraction of algebraic fractions. Now, under algebraic fractions, what we want to explore we want to be able to define what algebraic expressions are. After we have defined algebraic expressions, we then want to look at simplifying the algebraic expressions and then addition and subtraction of algebraic expressions. For this video, that's what we are going to do. In a subsequent video, we shall be looking at the multiplication and division of algebraic expressions. Now, for algebra or basic algebra exploration, we have done some navigation. We have navigated an introduction into algebra, and then we looked at the distributive law, followed by factorization, and now we are right here at algebraic fractions. Our next topic that we want to cover, after we have completed algebraic fractions, is equations and inequations. So stay tuned to all these videos as we work with you to develop your understanding in algebra and basic algebraic concepts. So, we are looking at algebraic fractions, and of course, the first question that will pop up in your mind, anything that you encounter that is new, the expectation is that you are going to try to understand what it means. So here, we want to know what it means when we say algebraic fractions. Now, for us, we have defined algebraic fractions as fractions where either the numerator or the denominator or both of them are algebraic expressions. Some examples of such, now bear in mind that when you are working with fractions, let's say we had the fraction 3/4. The numerator was whatever was above the vinculum, that's what we call that line, whatever was above the vinculum, and the denominator was whatever is below the vinculum. So we are saying here for algebraic fractions, and something is defined as an algebraic fraction if the numerator or the denominator or both are algebraic expressions. So some examples of those are these. For a plus 5 upon 3, you recognize above the vinculum, I have 4a plus 3. And if you had seen one of our previous videos, you would know that 4a plus 3 is an algebraic expression. So here, in the numerator, we have an algebraic expression. This here is an algebraic fraction. Other algebraic fractions are 2 upon 3x. Here, the 3x is an algebraic expression. And all of these here are examples of algebraic fractions. So now we know what algebraic fractions are. Of course, the next question is, so I know what something is. The next question that pops up in your head, of course, is, what do I do with it? So, what can we do with algebraic fractions? Now, the first thing that we want to show you that can be done with algebraic fractions is the simplification of algebraic fractions. Now, let's recall for me that when you are working with your regular fractions, you had to do something called reducing the fraction to its lowest terms. So when we say reducing a fraction to its lowest terms, what do we mean? Let's look at an example. Look at this example here. Reduce the following fraction to its lowest term. My fraction here is 30 upon 50, where 30 is the numerator and 50 is the denominator. How do we do that? Recall the steps for me. The first thing that you are going to do, the first rule or the first step that you have is to do what? To write both the numerator and denominator as a product of their prime factors. Now, I know for some of you, you are going to look at it and immediately upon looking at it, you would recognize what the common factors are. And so you can factor them out. And that's okay. But some of us, if you're like me, you need to know what the steps are and what the steps which must be employed in order to reduce the fraction. The steps we are saying here are these, that we need to write both numerator and denominator as a product of their prime factors. So let's do that for 30 upon 50. 30 as a product of its prime factors, and if you don't know how to write a number as a product of its prime factors, I encourage you to continue looking at our videos, because we have a lot of videos that would share a lot of the information that are necessary to ensuring that you fully understand the concept of algebra and the concepts in mathematics thoroughly. So writing 30 upon 50 as a product of its prime factors. 30 as a product of its prime factors is going to be 2 times 3 times 5. And 50 as a product of its prime factors are 2 times 5 times 5. So now that we have step 1 complete, write as a product of their prime factors. The next thing that we need to do is that we need to cancel out the common factors. So looking at our numerator, looking at our denominator, what are our common factors? We are saying that if we look here, you see that there's 2 in the numerator and 2 in the denominator. That's a common factor. So let's cancel that out. That's cancelled out. We cross it out. Do we see any more common factors? Of course, 5 appears to be common. So let's cancel out those 5s as well. So what are we left with? We are left with 3 in the numerator and 5 in the denominator. So therefore, our answer here, this being reduced to its lowest term, is going to be 3 upon 5, reducing it to its lowest term. Let's look at another example. Remember the steps that you must employ. The steps that you must employ are 1. Write both numerator and denominator as a product of their prime factors. And step 2, cancel out the common factors. So let's look at another example. What if we had 30 upon 45? Again, first step, write them as a product of their prime factors. So 30 upon 45 as a product of its prime factors would give me 2 times 3 times 5 all upon 3 times 3 times 5. Again, look for common factors. Wait, I see here that my 3 has already been cancelled out. The computer is playing games with me. So the 3 has already been cancelled out. You recognize as well that the 3 is common. So we cancel out the 3, and we need to, are there any more common factors? Of course, the 5 is also common. So we cancel out the 5. What are we left with here? In the numerator, we are left with 2, and in the denominator, we are left with 3. So it's going to be our answer here, reduce 30 upon 45, reduce as a fraction to its lowest term, is going to be 2 upon 3. Correct is right. Let's look at another example. 42 upon 63. Again, what are the steps? In mathematics, there are some basic steps that once you adhere to them, you should never go wrong. So you need to firstly know what the steps are, develop an appreciation for the steps, and then utilize these steps as you navigate, as you go about working your problems. So now, we are looking here at 42 upon 63. First step is to write both numerator and denominator as a product of their prime factors. So, writing numerator and denominator as a product of their prime factors here, we have it's going to be 2 times 3 times 7, 42, product of prime factors, and the denominator is 63, written as a product of its prime factors, it's 3 times 3 times 7. Next step is to cancel out the common factors in both numerator and denominator. So what are common factors here? Yes, correct is right. You are seeing 3 both in numerator and in denominator. Let's cancel them out. But also, are you not seeing 7 as well? I am seeing 7 as well. 7 is a common factor, so we cancel it out as well. What are we left with here? In the numerator, we are left with 2, and in the denominator, we are left with 3. So this here is going to be 2 upon 3. And we have reduced all of these fractions that we started with to a fraction in its lowest term. So now that we have recalled how to do the reduction of the regular fractions, can we then utilize these same steps to do reduction of algebraic fractions? What I want to let you know is this, that an algebraic fraction at the end of the day is a fraction. So most likely, the steps that you would utilize in working your regular fractions, those are the very same steps, modified slightly, that you need to utilize in working algebraic fractions. Let's look at some examples here. So we have looked at simplifying fractions, or should I say, reducing a fraction to its lowest term. Now what we want to look at here now is simplifying algebraic fractions. And again, we want to reinforce that algebraic fractions are fractions. So the rules that you would utilize in navigating or working problems involving fractions are the same problems, or same rules, that you need to utilize for algebraic fractions. So look at this example here. We want to simplify x squared minus xy all upon 3x minus 3y. And so we need to know what our rules or steps are. Our rules or steps are that we need to write both numerator and denominator as a product of their factors and cancel out the common factors. Now, when we say that, what we mean, for us here in algebra, writing the numerator and denominator as a product of their factors, we are saying that you really need to factorize the algebraic expression. So it's factorization of the algebraic expressions. So in a previous video, we looked at the factorization of algebraic expressions. I want you to just take a look at it before you continue. So now that you have looked at that video and you have a better appreciation for the factorization of algebraic expressions, let's utilize those tools that you got from that video to factorize the expression that we have in the numerator and the one in the denominator. Factorizing those expressions, in the numerator, we recognize that x is common. X is common, so we factor out that common factor. Factoring out the x, it becomes x multiplied by x minus y. And if you look at the denominator, what is common is the 3. So it's 3 multiplied by x minus y. So we have completed the first part. That is, to write both numerator and denominator as a product of their factors. The next step now is to cancel out the common. We need to cancel out the common factors. So let's cancel out our common factors here. Common here, in the numerator, I have x minus y. In the denominator, I have x minus y. And here, thanks, computer, the computer has cancelled them out for me. So what am I left with? I'm left with here, x on the numerator and 3 in the denominator. So what we have here now is x upon 3 as our answer. So correct is right. Let's look at another example. Looking at another example here, we want to simplify. What are we simplifying now? We want to simplify x squared y minus xy all upon x squared minus 1. To simplify that, again, we are saying that we need to remember what the rules are. The rules here are to write both numerator and denominator as a product of their factors, and then we cancel out the common factors. Looking at the numerator, in the numerator, what are our common factors in the numerator? Remember, if you have forgotten this, or if you need to do a little recap on factorization, you can check one of our previous videos. So in our numerator being factorized, I am seeing as if xy is common. So xy is common, we factor out the xy. And what about the denominator? The denominator, this denominator here, represents a case of difference of two squares. So how do we factorize difference of two squares? To factorize difference of two squares, we need to do this. So it becomes now, factoring out the numerator, it is xy into x minus 1, and the denominator is x squared minus 1. Factorizing that, we have x minus 1 multiplied by x plus 1. Now that we have done that, we have written both numerator and denominator as a product of their factors. The next thing that we do is to cancel out the common factors. In my numerator and my denominator, what do we have that is common? Correct is right. X minus 1 is common. So we need to factor it out. We factor out the x minus 1 in the numerator and in the denominator. So it cancels out. Yeah? So this therefore becomes xy all upon x plus 1. And we have completely simplified this algebraic fraction. Let's look at two more examples, shall we? Look at this one. Oh, this one looks nice. This is x squared minus 3xy minus 4y all upon 3x plus 3y. Again, what are our steps or what is the rule? The rule is what? The rule is to write both numerator and denominator as a product of their factors and to cancel out the common factors. So here, writing both numerator and denominator as a product of their factors, what we need to do is that we need to do some factorization. So we need to factorize the numerator and factorize the denominator. Again, I reiterate, if you are not too familiar with the factorization of algebraic expressions, please check one of our previous videos. We did that especially for you. So factorizing the numerator and the denominator, what do we get? We get here that it is going to be x plus y multiplied by x minus 4y all upon 3 multiplied by x plus y. Then the next step is to cancel out the common factors. What are our common factors here? When I look at numerator and look at denominator, the common factors are x plus y. So we cancel out those common factors. And what are we left with? we are left with x minus 4y all upon 3. And that is the way that we simplify this algebraic fraction to its lowest term. Look at another example. We have simplifying q squared plus pq all upon p squared minus q squared. Again, what we need to do is to write the numerator and denominator as a product of their factors. That's the steps, right? Let's check and see. Are those the steps? Where are the steps? Here the steps are. So we are writing both numerator and denominator as a product of their factors. And then we cancel out the common factors. So let's write, remember, in order for us to do that, we need to do some factorization. So doing some factorization, we are going to write the numerator and the denominator as a product of their factors. Now, when I look at the denominator, what's in the bottom, when I look at the denominator is a case of difference of two squares. We need to factorize this case of difference of two squares. Factorizing it also factorize the numerator as well. In the numerator, q is common. So we factor out the q, and we are doing a case of difference of two squares in the denominator. We then evaluate the new expression in the factored format, and we determine whether or not common factors exist. Do we have common factors? Of course we do. It is p plus q. So what we need to do is to factor out those p plus q, or cancel them out. So p plus q, factored out or cancelled out, we are left with q all upon p minus q. Now you don't necessarily have to write the brackets. So we have looked at simplifying algebraic expressions utilizing and factorization. We want to now move on a bit and look at some additional things that we can do with algebraic fractions. Of course, we can add and subtract algebraic fractions. Remember what I said, that most of the things, if not all of the things that you can do with your regular fractions, you can do with algebraic fractions. Woof! I seem to be sweating. Yes, maths does make you sweat from time to time, but that's okay. Sweating is an important part of building and developing. So let's develop, and let's develop mathematically. All right, so addition and subtraction of algebraic fractions. Let's see. I want you to recall with me. The steps that you would employ for addition and subtraction of your fractions. What are the steps that we would do when given your regular fractions to do some additions with? What would you do? The steps not the same for algebraic fractions. Let's see. So I want to make some attempts at evaluating. What am I evaluating? 5 upon 6 plus 3 upon 8. What do we do when we are asked to evaluate our fractions? Of course, what are the steps? The steps here are, or should I say questions you must ask yourself. What questions should you ask yourself? Question number 1. What is the lowest common denominator, LCD or LCM, lowest common multiple? What is the lowest common multiple or lowest common denominator? By that we mean that we are going to compare our denominators. My denominator here is 6, my denominator here is 8. For these denominators, we want to determine what is the lowest common multiple or lowest common denominator. By that we are saying that here's what? 6 can divide 12, can it not? 6 into 12 is 2. 6 can divide 18. 6 into 18 is 3. Yes, what about 8? 8 can divide 16. 16 or 8 into 16 is 2. 8 can divide 24. 8 into 24 is 3. So we are saying that here's what. We need to find a singular number. A singular number. When we use 6 and 8, they both can divide that number completely. How do we do that? What system do we have to do that? Here's what we do. So we want to get our lowest common denominator. The system that we have to do that is to first write out those denominators. What are my denominators? 6, 8. Good. We then ask ourselves this question. Outside of 1, what is the smallest number that can divide these numbers or these denominators? Of course, that number is 2. Now here's it. I don't just want the smallest number that can divide them. I want the smallest number that can divide either of them or all of them. Yes? So if it can divide only one, we are still going to use it. If it can divide both of them, we are going to use it as well. So either or. So looking here, the smallest number you are saying is 2, of course. 2 into 6 is what? 3. And 2 into 8 is 4. So we are going to end up with here 3 and 4. we have to repeat that process again. Repeat that process for me. What is the smallest number that can divide either? Now we have 3 and we have 4. What is the smallest number that can divide 3, 4, or both? That is going to be what? I'm saying 2 again. Because 2 can go into 4, can it not? So we are saying it's 2. Can 2 go into 3? No, it cannot. Of course not. Now, hear this thing for me. It is very important that you recognize now that your development, your success in mathematics is dependent on you having some basic knowledge. One of the basic knowledge that you must have is your knowledge of your timetables. So you must, if you don't know it now, that's okay. But you need to, as we progress along our journey in mathematics, you need to learn your timetables. It's very important in mathematics and for your understanding of advanced concepts. So here, we are saying, can 2 go into 3? We are saying, of course not. What then do we do? 2 can't go into 3, so we are going to write back the 3. Can 2 go into 4? Yes, 2 can go into 4. 2 into 4 is what? 2 into 4 is going to be 2. It can't go into 3, so we write back the 3. We look again at what the numbers that we have produced. And we are going to ask ourselves again, what is a common factor? What number can divide either one of them or both? The smallest number we're going with, right? So the smallest number here is again going to be 2. Can 2 go into 3? Cannot. So we are going to write it back. Correct is right. And can 2 go into 2? Yes, then my answer is 1. We then look here. We have 3 and 1. So we are asking ourselves, what is our common factor? Our common factor here, no, not common factor, but what number can go into either the 3 or the 1? And again, the number has to be bigger than 1. We know 1 is a factor of all numbers, right? Good. So that number here is going to be 3. 3 into 3 is 1. 3 into 1 cannot, so we write it back. So we are left here with 1, 1. Once we have gotten to this spot where all the denominators are now 1, or all the numbers here, sorry, are now 1, we then are able to make a prediction that our lowest common denominator, or lowest common multiple is what? It is taking all of these numbers and we multiply them. So our lowest common denominator is going to be take all these numbers and multiply them. So it's going to be 3 times 2 times 2 times 2. And that, the product of those, gives us our lowest common denominator. Oh, I'm sweating, boy. This maths thing is getting me all excited and worked up. I like the maths. You like the maths? I like the maths. So we go. Lowest common denominator here is what? Our lowest common denominator, when we multiply these, 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. Lowest common denominator here is 24. So what next do we do? So we have determined our lowest common denominator. The question is, what next do we do? What do we do next? We need to determine how many times must each denominator be multiplied to give our lowest common multiple or lowest common denominator. So that's what we need to do next. So we come here now. My denominator here is 6. How many times must I multiply 6 to get 24? 6 multiplied by 4 is 24. So we then take that 4 and we multiply that 4 by the numerator. So it's going to be 4 multiplied by 5. Plus, how many times can I multiply 8 to give me 24? It's going to be 8 times what is 24? 8 times 3 is 24. So we take this 3 and we multiply by the numerator. So it becomes 3 times 3. And then we simplify. Simplifying here now we do, what is 4 times 5? 4 times 5 is 20. And what is 3 times 3? 3 times 3 is 9. All upon my common denominator. And then I further simplify. What is 20 plus 9? 20 plus 9 is 29. All upon my common denominator, that's 24. And so my answer here is 29 upon 24. I know that in fractions you're usually asked to write this as a mixed number. But for our purposes, we are going to leave it right here. So let's now go and look at addition and subtraction of algebraic fractions. What did I say? Yes, because so far what we did was to do addition of fractions. And we have argued that the same steps that you employ to do addition and subtraction of fractions are going to be the same steps that you are to employ to do addition and subtraction of algebraic fractions. So take a look at this for me, and let me just dab my forehead a bit. This math thing is getting me all worked up and excited, so I'm sweating slightly. So let me dab my forehead a bit. You take a look at this, and then we move on to the addition and subtraction of our algebraic fractions. Right, so my forehead has been dabbed. Are you ready for me? Addition and subtraction of algebraic fractions. Let's see. Maths working me up here. I like this workout here. It's a nice workout. Maths really nice. So look here. Simplify 5x upon 6 plus 3x upon 8. I know for some of you, you have already recognized something here. That the denominator from the previous problem is the same denominator I have here. So of course, the steps or the rules that I would employ are going to be the same. What questions should you ask yourself? The question that you must ask yourself again is, 1, what is the lowest common denominator or the lowest common multiple of my denominators? Again, remember or recall for me, the denominators that I use here are the same denominators I used previously. But we're still going to work it through, right? So firstly, we take our denominators. What are they? 6 and 8. And we ask ourselves, what is the smallest number that can divide either the 6 or the 8 or both? In this case, it's going to be 2. 2 into 6 is 3. 2 into 8 is 4. Then we do it again. For these numbers that have been produced, we ask ourselves, what is the lowest number that can divide either or both? Again, it's going to be 2. 2 into 3. 2 can't go into 3, so we are going to write back the 3. And 2 into 4. 2 into 4 is 2, so it gives us here 3 and 2. Again, we try the process again. What is the smallest number that can go into either 3 or 2 or both? In this case, that's going to be 2. 2 into 3 cannot, so we write it back. And 2 into 2 is 1, so we have our 1. We then try again. In this case, we have 3 and 1, and we are saying that the number that we're looking for to divide here has to be greater than 1. So in this case, the only thing that is left is the 3. So we try the 3. It's going to be 3 into 3 is 1, and 3 into 1 cannot, we write back 1. So we end up with here in the bottom here, all 1s, and we're good to go. We can now make that prediction. What is our lowest common denominator? Our lowest common denominator here is going to be all of these numbers multiplied. All of these numbers multiplied, 3 times 2, 6, 6 times 2, 12, 12 times 2, 24. Our lowest common denominator here is the product of these being multiplied, which gives us 24. We expected it to be 24, right? Because the denominators were similar or are the same as the ones from the problem before. So my lowest common denominator here is 24. And then we ask ourselves, what question now? Where's that question? Come, question, where are you? Question, he's here, right? How many times must each denominator be multiplied to give the lowest common multiple or lowest common denominator? Again, the computer seems to be ahead of me here. I think we're playing a game. So he has already told us that 6 times 4 is 24. We are going to take that 4 and we are going to multiply that 4 by the numerator. It's going to give us 4 times 5x. And we're doing it the same thing to the next side. So what can we multiply 8 by to give us 24? And that is going to be, let's see, that is going to be 3. Correct is right. So 8 times 3 is 24. We take this 3 and multiply it by our numerator. So it's going to be here now 3 times 3x. And in a previous video, we looked at the steps that we needed or the rules that we needed to follow in order to do multiplication of algebraic terms. So we want to apply those steps here now. So it's 4 times 5x. What is 4 times 5x? And it's 3 times 3x. What do we get here? 4 times 5x, well, my common denominator, that's him there. 4 times 5x is 20x, and 3 times 3x is 9x. Correct is right. So now what we need to do is that we need to now add our numerators. Again, remember, in a previous video, we did addition and subtraction of algebraic terms. Once they are like terms, we can add them. So these terms are alike, we can add them. It gives us 20x plus 9x is going to give us 29x all upon 24. And we have simplified this algebraic expression here. This maths thing, really nice.